Hello, my name is Amir. I'm an 11th grader at Renaissance High School and a student scientist at Ecotek Lab. My career focus is in mechanical engineering, and today I'll be presenting the science behind additive manufacturing. Over the summer, I participated in the engineering program at Michigan Technological University, where I learned of the many different engineering fields that they do there, as well as the NAV program at the University of Michigan, where I worked in CAD design and 3D printing, which allowed me to better further my skill in CAD design. The main form of 3D printing I use is called FDM printing, which is printer melts down a filament, deposits it on the build plate, and layers it on top of each other until the part is complete. One of the filaments that I've used in this field is PLA, which is a relatively easy filament to melt. Now I am back in the lab, and I will show you how to design and print airless basketball. First, you need to find a software that you'll use for slicing. The software that I use is called Cura. You need to make sure that your file has the proper size and is correctly placed on the build plate. Then you will need to slice your file here. The 3D CAD model of the airless basketball that I printed here. The base unit for measurements inside this Cura software is millimeters. So when printing your file, you need to know the difference between millimeters, inches, centimeters, and make sure that its measurements are correct. On the software, you're able to see all angles of the print. Here, I can look under the build plate to see if there are any errors in the print. I'm also able to zoom in to make sure that all the hexagonal designs are correctly inside the printer. And then, once your file is sliced, for an Ender 5 S1 printer, you would download it to the flash drive here. Now, I will go into detail about converting STL files to G-code files. Using Cura, when you slice a file, it converts it from an STL file to a G-code file, because G-code files are how the 3D printer is actually able to print the file. Now, when the file is sliced, it adds things like supports, and it will tell you how it would be actually printed in the real world. As you can see here, these blue hollow pieces here are supports that were used to print a football that I printed myself using TPU. The red part is the part that is actually a part of the 3D model that I had used, and the blue part is the supports. And it also shows this line here that when the printer prints, it prints this just to make sure that the filament will actually print properly. So once you download the file from your computer to this flash drive here, what you do is you take this piece off of it and insert it into the printer. So now, when you return to the print page, you'll be able to see all the prints on that hard drive that you'll be able to print. So this is the control panel for the 3D printer. This is the home page to tell you what the heat level is on the build plate and the extruder. The next page is the print page, which will show all the possible prints you have already installed on the printer. Next is prepare, which you're able to determine the location of the extruder or the build plate. And you're also able to reset them and level them. This shows the leveling method and also preheating. This 3D printer has 3 axes. The Z-axis is with the build plate files, which is up and down. The X-axis is with the extruder files, which is left and right. And then the Y-axis is forward and backward, which is with the extruder files as well. PLAB has the property of allowing prints made with it to bounce. So as you see, no damage was sustained by the ball, and it was able to bounce back up to me. TPU makes prints more flexible, but does not allow them to bounce. As you can see, I'm able to squish this print in, and it is also a lightweight filament. Standard PLA is more hard. As you can see, I'm not able to bend it or move it. Now I'm going to go over some of the parts that I use on 3D printing. First, I have to build a 3D printer, which requires me to use these wrenches to use. Next, after a print is done and I need to get it off the build plate, I typically use this scraper if it's hard to remove. This is what I use whenever I need to get stuck filament out of the extruder, like this here. And here is the hard drive that I use when I need to convert files from my computer to a G-code and put them into the printer. I will now go to the gym and test out the 3D printed football and basketball. My time at Ecotek Lab has taught me to be more creative in my ideas, to follow through with the projects I choose, and the value of hard work.